morning, Doctor. My name is Kamyunam from VMFV S1/1. I will be explaining question 1 of the statics assignment. First, we will go to the point G in the diagram. We will draw the free body diagram, and from here, we can calculate the forces of the FG and FGH and FK, FG. First, we'll go from the x-axis. So, from the x-axis, FFG cos 30 minus FGH cos 60 is equal to 0. As such, we can determine that FFG is equal to 3 over 3 FGH. And then we use that and insert into the Fy equation, which is FGH sine 60 degrees minus FFG sine 30 degrees minus 25 equals to 0. From there, we can determine that FGH is equal to 21.65 kilonewtons. And inserting it into the previous equation, we can find that FFG is equal to 12.5 kilonewtons. And then with these numbers, we can move on to point H. After drawing the free body diagram, we can use it to find the values. First, we will use the Fy axis, which is FHI sine 30 degrees plus 21.65 sine 60 degrees is equal to 0. So here you can determine that FHI is negative 37.5 kilonewtons. And from the free body diagram, we can determine that it is a compressive force. And then we can use it in the Fx equation, which is FH minus 37.5 cos 30 degrees minus 21.65 cos 60 equals to 0. From there, we can determine that FFH equals to 43.3 kilonewtons, which is a tensile force. And then we can move on to point I. After drawing the free body diagram, we can find the Fx first, which is 37.5 cos 30 degrees plus Fi cos 60 minus Fij cos 30 degrees. And after calculating, we can determine that Ffi is equal to 2 times bracket Fij cos 30 degrees minus 32.48. And then we can insert that into the Fy function, which is 37.5 sine 30 degrees minus Ffi sine 60 degrees minus Fij sine 30 degrees equals to 0. From there, we can determine that Fij is equal to negative 18.75 kilonewtons, which from the free body diagram is compressive force. And then we can use Fij we can find Ffi, which is negative 97.44 kilonewtons, which is a tensile force. And then we can go to point F. After drawing out the free body diagram, we can use it to find the values. First is Ffy. Fy equals 0. So first is FFJ sine 60 degrees plus 67.44 sine 60 degrees plus 12.5 sine 30 degrees. We can determine that FFJ is equal to negative 104.66 kilonewtons, which is a compressive force. And then we can insert that into the Fx equation, which is FEF plus 12.5 cos 30 degrees minus 104.66 cos 60 degrees minus 97.44 cos 60 degrees minus 43.3 equals to 0. And then we can determine that FEF is equal to 133.52 kilonewtons, which is a tensile force. And then we can come to point J. After drawing out the free body diagram, we can start with the Fx axis, which is Fjk cos 30 degrees plus Fej cos 60 degrees plus 104.66 cos 60 degrees plus 87.4 cos 30 degrees. From there, I can determine that the equation will that Fej is 2 times 32.06 minus 0.8666 Fjk. We can insert that into the Fy values into the Fy axis and find the equation is Fjk is sine 30 degrees plus 104.66 sine 60 degrees minus 97.44 sine 30 degrees minus Fej sine 60 degrees equals to 0. From both these equations, we can determine that Fjk is equal to 97.45 kilonewtons, which is a tensile force. And then we can use that to find FEJ, which is negative 104.66 kilonewtons, which is a compressive force. Okay, after that, from the diagram given, we can see that both left and right sides are the same. As such, we can use them to determine the forces of Fe and Jk. For example, FPQ is equal to Fe, and such FPQ is equal to 103.52 kilonewtons as well. And then FKL will also be equal to FJK, which is 97.45 kilonewtons. Okay, now we move on to point K. From the diagram given, we can use the values to determine that the tangent data is equal to 6 over 12. Calculating, we can get the data is equal to 26.57 degrees. With that, we can find the fx value first, which is 97.45 cos 26.57 plus fkq cos 86.57 minus 97.45 cos 26.57 minus fke cos 86.57 degrees, which is equal to 0. With that, we can get that FEK is equal to FKQ. With this, we can use it in the FY circuit, the calculation, which is 97.45 sine 26.57 plus 97.45 sine 26.57 plus FKQ sine 86.57 plus FEK sine 86.57 equals to 0. From this and this, we can determine that both FEK and FKQ are equal to negative 46.67 kilonewtons, which is a compressive force. Now we move on to point Q. After drawing out the free body diagram, we can determine, since this is a 30-degree angle, we can use it at the 86.57 degree angle to determine that the delta is equal to 63.43 degrees. With that, we can use it to find the Fy axis, which is 43.67 sine 86.57 plus 104.66 sine 43.43 minus FQR sine 87.57 degrees equals to 0. After calculating this, we can determine that FQR is equal to 136.44 kilonewtons, which is a compressive force in this free body diagram. And then we can use it to find Fx, which is 133.52 plus 43.67 cos 86.57 minus 104.66 cos 63.43 minus 136.44 cos 86.57 degree minus FEQ equals to 0. Now you can determine that FEQ is equal to 81.16 kilonewtons, which is a tensile force in the diagram. After that, we move on to point E. After drawing out the free body diagram, first we will use a projector to determine that the degree angle here is equal to 75. With that, we will use it to find the Fy first, which is 43.67 sine 86.57 plus 104.66 sine 63.43 plus FER sine 75 plus FDE sine 86.57 is equal to 0. With that, you can determine that FER is equal to negative 1.03 FDE minus 104.0404. And then we can use that in the Fx equation, which is FER cos 75 minus 43.67 cos 86.57 plus 104.66 cos 63.43 minus FDE cos 86.57 plus 81.16 minus 133.52 is equal to 0. And then using both of these equations, we can determine that FDE is equal to negative 137.62 kilonewtons, which is a compressive force. With that, we can also derive that FER is equal to negative 0.29 kilonewtons, which is also a compressive force. After that, we will move to point R. After drawing the free body diagram, we will use it to find the Fy, which is FRS sine 93.43 degrees minus 0.29 sine 75 degrees minus 136.44 sine 86.57 degrees equals to 0. And now we can determine that FRS equal to 136.72 kilonewtons, which is a compressive force. And then we can find the Fx equation, which is FDR plus 0.29 cos 75 degrees plus 136.44 cos 86.57 minus 136.72 cos 93.43 degrees, which is equals to 0. Well, now we can determine that FDR is equal to negative 60.72 kilonewtons, which is a tensile force in the free body diagram. After that, we'll move on to point B. By drawing out the free body diagram, we can use a projector to determine that the degree is equal to 66 degrees. The theta is equal to 66 degrees. With that, we will find the Fy equation, which is 137.62 sine 86.57 plus FCD sine 86.57 plus FDS sine 66 equals to 0. From there, we can determine that FDS is equal to negative 1.09 FCD minus 150.37. And then we can use that, and then we will find the Fx equation, which is 60.42 plus FDS cos 66 minus 137.62 cos 86.57 minus FCD cos 86.57 equals to 0. From these two equations, we can determine that FCD is negative 105.28 kilonewtons, which is a compressive force in the equation, in the diagram. With this, we can also find FDS, which is equal to negative 35.61 kilonewtons, which is also a compressive force in the free body diagram. Finally, after finishing all the diagrams, we can determine that member KL is equal to 47.45 kilonewtons, member PQ is equal to 133.52 kilonewtons, member FH is equal to 43.3 kilonewtons, member EJ is equal to 104.66 kilonewtons, and member DS is equal to 35.61 kilonewtons. That concludes question 1.
Hello, my name is Mugilan, son of Ravindran, matrix number B0922104333, and I'll be doing questions 2 and 3 of the statics assignment. So let's start off with question number 2. I've already drawn the free body diagrams and I've written all the equations, so I'll be explaining that. This is the first free body diagram. This is to show that this free body diagram, all points and the components of those points are in equilibrium. Hence, we use summation, equation of equilibrium, summation of moment about point A equals 0. With that in mind, dx equals 0, ax equals 0, and bx is also equals to 0. Moving on to the second free body diagram, we have points B and C, as well as another point where the force is acting, 300 Newton. Components Bx and By of point B with their distances, as well as components Cx and Cy of point C. So from this free body diagram, we are going to use equation of equilibrium to get By. So we are using clockwise as positive, and we don't know which direction are the forces acting towards, so let's assume tensile outwards. So summation of moment about point C equals to 0. Summation of moment about point C equals to 0. Hence, point C, we start off with By. By is here, so it will be pushing upwards clockwise. Formula of moment is force times by perpendicular distance. So positive By times by 12 times 10 to the power of negative 3, converting millimeter into meter, plus 300, force 300 clockwise, 460 minus 12 to get the distance, times 10 to the power of negative 3, conversion from millimeter to meter, minus Bx, we are having here, so So Bx goes anti-clockwise, hence negative, times 24 times by 10 to the power of negative 3 equals to 0. Solve that equation and we will get By equals 11,200 Newton in tensile as it is positive. That will be our first equation. Moving on to the third free body diagram, we have 3 points. Force F, point A with the components Ax and Ay, point B with components By and Bx, as well as their distances. So using equation of equilibrium, assuming clockwise is positive and forces are in tensile, summation of moment about point A equals 0. So this will be our point A. Negative F is pushing downwards, so anti-clockwise. Negative F times by the perpendicular distance, 24 times 10 to the power of negative 3, plus By. By is pushing down, so it will be clockwise positive. 96 times 10 to the power of negative 3 equals 0. Solve that equation and we can get F equals 4By, which will be our second equation. The final step to solve this question is by substituting equation 1 into 2. So we have F equals 4By, and we found out earlier that By is 11,200 Newton. Substitute that into By, and the final answer force F is equals to 44,800 Newton in tensile. It's going outwards. Okay, moving on to question number 3. We have question number 3 asks 3 different questions. One is the force on member AB, force on member CD, and then it asks B, which asks for force on member FH, as well as C, the force exerted by pin G. So let's start off with the first one, A. This is the free body diagram of the bucket which carries the load. So first off, as the question mentioned, only half of the load is supported, so we divided weight. So we have 1,500 meter from that. And then we use equation of equilibrium. Summation of moment about point D, assuming clockwise is positive and forces are in tensile force. So point D, FAB is pushing clockwise, so positive times by the perpendicular distance, minus 1,500, which is pushing anti-clockwise, times by the perpendicular distance equals 0. Hence FAB, we get 1,500 Newton in tensile as it is positive. So FAB is going outside. Moving on, this is our second free body diagram. We have points B, C, D, and E. E has its component in EX and EY axis. FAB, there's an angle for FCD, and these are the distances between them. So first off, find theta. We are going to use tangent theta, 0.2 over 0.1. So inverse tangent it, and theta will equal to 63.43 degrees. And then moving on, we are going to apply the equations of equilibrium. Starting off with summation of moment about point E, clockwise positive, and assuming it's in tensile. So about point E, we have 1,500 FAB pushing anti-clockwise, hence negative. 1,500 times by the perpendicular distance total all the way to point E, and then we have FCD cos 63.43, which is this. It is going clockwise, and then the perpendicular distance minus FCD sin 63.43 times by the perpendicular distance 0.1 equals 0. Solve that equation and we will get force acting on cylinder CD equals 10058.4 Newton in tensile as it is in positive. So FCD is right over here and it is in tensile. Moving on, we are going to use the second equation of equilibrium. Summation of forces at x-axis. Going to the right is positive and we assume that it's in tensile force. So summation of forces in x-axis equals to 0. Hence, EX is going to the left, so negative EX plus by 1058.4 cos 63.43, FCD is going to the right, hence plus, minus 1500 Newton, FAB is going to the left, equals 0. Solve the equation and you'll get EX equals to 2999 Newton in tensile. And then the third equation of equilibrium, summation of forces in y-axis equals to 0, we assume that downwards is positive and the forces is in tensile. So we have negative 1058.4 sine 63.43, which will be this is going upward, hence negative, plus Ey is going down, so positive, equals 0. Solve the equation and you will get Ey equals 8996.12 Newton in tensile force, and it is going outward. These two equations will be required in the next part. That is why we did it earlier. The answer for A is FAB 1500 Newton and FCD 10,058.4 Newton. Moving on to question B, this is the free body diagram. We have points E, E, F, G and H. G has its components Gx and Gy. F has an angle over here, theta 2. D has an angle over here, theta 1. This is the force acting on D, forces acting on Ex and Ey, force of cylinder FH, and the perpendicular distances. So first off, we are going to find the angle of theta 1 sorry, and theta 2. So we are going to use tangent theta as always, and calculating the perpendicular distances. So solve that, theta 1 you will get inverse tangent. Theta 1 will be 21.80 degrees, and then theta 2 inverse tangent you will get 45 degrees. So, and then we apply our equation of equilibriums, starting off with summation of moment about point G. So assuming clockwise is positive and forces are in tensile. So negative FFH, we are going clockwise, but this is going anti-clockwise. Sine 45 times by the perpendicular distance, 0.15 plus force FH, cos 45, 0.6, and so on. 2999 times 0.15 plus 0.3 plus 8996.12 times by the perpendicular distance, 0.5 plus 0.6, and so on. We find out all the forces acting about moment about point G, and you will get this equation. Solve the equation and you will get force FH equals 6809.05 Newton in tensile. And then we apply our second equation of equilibrium, which is forces, summation of forces on the y-axis equals 0, assuming that downwards is positive and forces are in tensile. So we have 10,058.4 sine 21.8 degrees. Should be this. It is going downwards, hence positive. Minus 8996.12. 8996 is going upwards, so we have negative. And then FFH, which is a 36809.05 cos 45, it is going negative as it is going upwards. Plus Gy is going upwards, equals 0. Solve the equation and you will get Gy equals 31288.68 Newton, forces in tensile. And then the third equation of equilibrium, summation of forces on the x-axis equals 0. Assume that going right is positive and forces are in tensile. Negative 10,058.4 cos 21 degrees as it is going to the left, plus 2999 as it is going to the right, minus 36,809.05 sine 45 degrees, it is minus as it is going to the left, and plus gx is going to the right, equals to 0. Solve the equation and you get gx value, which is force is 32368 Newton and force is in tensile. So these two will be our forces exerted by pin G, as the question required in C. And force FH required by question B is this. That's about it for question 2 and 3. Thank you.
Good morning. My name is Dina Analaki Mananan. My matric is B0922104446. I'm doing question 4 and 5 in static 7. Okay. First, I'm doing question 4. The first question is when theta equals 0. Okay. I'm reading anti-clockwise. Summation of moment on point C equals to 0. 240 bracket 320 plus 180 times 10 power of negative 3 and will use to change mm to meter minus B bracket 160 times 10 power of negative 3 equals to 0. Okay, B bracket 160 times 10 power of negative 3 equals to 240 bracket 500 times 10 power of negative 3 bracket, and B we get 750 Newton. For summation forces on y-axis equals to 0, Cy minus B equals to 0, Cy equals to 750 Newton, and summation on forces on x-axis is equals to 0, Cx equal 240. For this diagram, this point to this point is 125 mm, this 200 mm. Okay. For summation forces on x-axis equals to 0, dx minus cs equals to 0, and dx we got 240 Newton. On summation on forces on y-axis equals to 0, dy minus cy equals to 0, dy equals to 750 Newton. Summation moment on point D, okay, md equals to 750 bracket 300 times 10 power of negative 3 minus 240 equals to 125 times 10 power of negative 3 bracket, and we got 195 Newton meter plus bracket anti-clockwise. And second one, they question us for when theta equals to 90. I'm using anti-clockwise. Summation moment on C equals to 0 minus 240 bracket 160 plus 90 bracket times 10 power of negative 3 plus B bracket 160 times 10 power of negative 3 equals to 0. B bracket 160 times 10 power of negative 3 bracket equals to 240 bracket 250 times 10 power of negative 3 bracket, and B we got 375 Newton. Summation on forces on y-axis equals to 0 minus 240 plus 375 minus Cy equals to 0, and Cy we got 135 Newton. Summation forces on x-axis equals to 0, and Cs we got 0. This summation on forces on x-axis equals to 0, Cx equals to dx and equals to 0, and summation on forces on y-axis equals to 0, dy equals to Cy, and dy we get 135 Newton, and summation moment on D is equal to 0, md equals to bracket 135 bracket 300 times 10 power of negative 3, and we got 40.5 Newton meter anti-clockwise. That's something for question 5. This figure diagram for question 5. Okay, for step 1, okay, summation of a moment on point D equals to 0. Minus 250 bracket 600 times 10 power of negative 3 plus FAE bracket 405 bracket 150 times 10 power of negative 3 equals to 0. 250 bracket 600 times 10 power of negative 3 equals to FAE bracket 405 bracket 150 times 10 power of negative 3, and FAE we got 1250 Newton. For step 2 is a figure diagram. For summation forces on y-axis equals to 0 minus 250 plus by minus 1250 bracket 405 equals to 0, and by we got 1250 Newton. For summation forces on x-axis equals to 0 minus 150 plus bx minus bracket 1250 bracket 305 equals to 0, and bx we got 900 Newton. So we can simplify AE parallel dengan BF parallel dengan DG is parallel to each other. So theta we got 90 minus 36.87, we got 53.30. For find x, I'm using tan 53.13 equals to 400 times 10 power of 83 divided by x. So x, you can simplify, we got 300 times 10 of 83. For y, I'm using cos 36.87. Y divided by 200 times power of 10 power of 83. So y, you got 160 times 10 power of 83. Anti-clockwise summation of movement on point F equals to 0. So bracket FDG bracket 160 times 10 power of 93 minus bracket 1250 bracket 300 times 10 power of 93 plus 900 bracket 400 times 10 power of 93, we got 0. So FDG, we got 93.75 meter. And finally for step 3, summation forces on y-axis equals to 0. Fy equals to 750 plus FDG bracket cos 36.87 bracket 750 plus bracket 93.25 bracket cos 36.87, and finally you got 844.55 Newton for y. For x, summation forces on x-axis equals 0. Fx equals to 600 plus FDG bracket 36.87 equals to 600 plus 93.25 bracket 36.87 equals to 656.35 Newton for x. That's all from us. Thank you for watching.